Hello everyone and welcome to this video on Lab 3, generating Z-scores in SPSS. And so in this lab we're going to use 2018 GSS data in SPSS to produce and interpret the following: calculating Z-scores, plotting histograms of original values and compared to standardized values, and observe and interpret differences between these standardized values and the original values for different variables. Let's get started. So the first thing we're going to do is we're going to go and we're going to start to generate those Z-scores. And so we're going to create a new variable in order to generate these Z-scores. So to get these Z-scores, we're going to go to Analyze, Descriptive Statistics, Descriptives. We're going to click here. So we're going to go here and we're going to switch this to Display Variable Names because I find that helpful. And we're going to find the Education variable. And we'll move that to the variables of interest. Now, we're going to click here and click Save Standardized Values as Variables. So we're going to click that. And we're going to hit OK. So here's some basic descriptive statistics about our dataset, which is highest year of school completed. But what we aren't shown here is that we have created a new variable. So it isn't indicated here, but SPSS has created a new variable containing the Z-scores for education. If we go to our data editor window here and go to the variable view here, and we scroll all the way down to the bottom, here we have a new variable called ZEducate. So ZEDUC. So the same thing as that EDUC variable, that education video, but this is going to be a standardized version of that variable. So again, creating Z-scores for each case in that data set. And so what we can do now is kind of compare what those education, that raw education or original data is, to these standardized variables. So we're going to go back up and we're going to go to Analyze, go back to Descriptive Statistics and Descriptives. And this time we're going to add education into our box. We're going to unclick the save because we don't want to save standardized variables of a standardized variable. And then we're going to click OK. And so now we can see a little bit about what's happened. We have our descriptive statistics here. We have the same number n, but now our minimum is going to be different for our standardized variables compared to our original, right? The minimum for our original data was 0, now it's -4. That is because we're using the middle, or the mean of our data set here as 0, and everything's going to be in relation to that. Because remember, standardized scores are all relative to that mean, to that middle in our normal distribution. So assuming this normal distribution, we know that 0, having 0 years of education, is -4.61679 standard deviations below the mean, while a maximum of 20, right? In our data set, you could have a maximum of 20 years of education. That is 2.10745 standard deviations above the mean. So everything's in terms of that relative to the mean. And what this means here is that our mean is 0. That's because, again, in a standardized data set, where we've converted things to Z-scores, the mean of those standardized scores is always going to be 0. One standard deviation is going to be whatever our standard deviation for that original data was. So let's also take a look at this using some frequency tables. So again, we're going to go to Descriptives. This time we're going to go to Frequencies. And we're going to add both education and Z-education to our variables. So first education, we'll scroll all the way to the bottom and add Z-education. And we'll click Go. Okay, so here's our original data showing the frequency, percent, valid percent, cumulative percent like we've seen before. We have a large group here. You can see that our mode here is 12 years of education, and our mean is 13, so we can get some basic information there. But let's compare it here. Notice that, again, everything is relative to that mean. So earlier we can see that our mean was 13.73. Obviously, we don't have any cases in our data set that have exactly 13.73, but you'll notice that the values get smaller the closer they are to that 13. So we can say, okay, 313 here is equal to 14 years of education, 183, 183. So we can kind of sit there and compare. 13 years of education is negative 0.24603 standard deviations below the mean, whereas 313, which is 14 years of education, here, 14 years of education, is, where was I? Sorry, 313, you gotta make sure you keep track. 313, using the frequency to keep track. 313 is 0.09018 standard deviations above the mean. So we can look here and see how far away each given year of education is from that mean and the frequency there. So that gives you an idea of how we can compare. If you need to find out, say, how far 8 years of education is below the mean, you can look 8. Okay, make sure you remember where that is. Oops, excuse me. 8, make sure you remember where that is. Scroll down. We can see that it's negative 1.927, blah, 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 standard deviations below the mean. All right, let's try graphing this now. So let's go and produce a histogram. So first I'm going to go to Graphs. I'm going to go to Legacy Dialogues. I'm going to go to Histogram here at the very bottom. So the first thing I'm going to do is I'm going to graph Education. Okay, so we're going to graph Education first. Hit OK. And then we're going to repeat this for the standardized variable. So we're going to go to Graphs, Legacy Dialogues, Histogram, and we're going to use our standardized variable here. All right, and what we can see here is that while the frequency distribution looks very similar, right? Very similar, same frequencies, we notice that again it's centered around this mean, and it is approaching a normal distribution. It's not quite there, but it is approaching a normal distribution. And so we can see that what we have here is a potential negative skew to some of our data, but in general it's approaching that normal distribution, and we can see that the graphs look very similar visually when we graph them. But again, instead of being from 0 to 25 or -5 to 25, I'm not sure why they add that -5 in there. We can see that it's in standardized units. So the units have changed, but the shape of the graph is still the same. Let's try doing this with a box plot. So again, I'm going to go to Graphs. I'm going to go to Legacy Dialogues. I'm going to go to that box plot here. And we want to just do simple, and we want to do summaries of separate variables. Summaries of separate variables. And we're going to hit Define. We'll start with Education. And we're going to hit OK. All right, so that's what our box plot is going to look like. Next, we're going to do the same with our Z, our standardized Z education variable. All right, so let's blow this up a little bit. So we can see that again, it's going to look very similar, but rather than being centered around the mean, right? This is the mean, and this is confidence interval around the mean. We'll get to those a little bit next week. The mean right here is 13.73, right? We can see where everything is in the outliers. Here you notice that it's really closely centered on 0. This should actually be centered on 0. Something's wrong graphically here. But this is centered on 0, where our mean should be. And so that's how the standardized look? It's going to have the same frequency distribution. It's going to look very similar, but it's going to be centered around a mean of 0 because we've standardized to that mean. All right, so take your time and go through this. Make sure you can do it before you start the lab activity assignments, before you start that quiz. As always, if you have any questions or issues, please let me know. Thank you, everyone.